And this is the reason why I started looking into event sourcing, sort of reverse engineer my way into microservices rather than the other way around data. So in order to talk about microservices and event sourcing, I think it's actually important to go back to the basics why microservices are important, because it's all built up. So previously we've had monolithic applications, traditional apps on the left, and these where the data was structured simply. Right? Moving ahead, now we have applications, a lot of data, unstructured, structured, and now we have to throw web scale data sets into the mix as well. So that's one of the reasons why microservices. So monolithic applications and microservices, silo teams, and cross-functional teams as well. So there's been numerous research done that sort of shows that cross-functional teams tend to perform better and they tend to produce faster results. So you have continuous delivery, sort of things, so continuous iteration is the goal. Now microservice architecture, I assume all of you guys are familiar with the definition. I'll read it out. So microservice architecture is a method of delivering software applications as a suite of independent deployable small modular services, with each service runs on unique processes, communicates through well-defined, lightweight mechanisms to serve a business goal. So why microservices? Build and ship code faster and cheaper. I think that these are the core principles and drivers for microservices. Reduction of complexity. So think about monolithic applications and complexity that tight coupling brings in. And we're trying to reduce complexity for the reasons above in order to be able to iterate faster, deliver code faster. Horizontal and vertical scaling. So horizontally scalable applications, monolithic applications previously. When we're moving into web scale data centers, I'm sorry, the other way around. Horizontal scaling is actually become really, really important. Then you tend to get into a world where you are actually creating a now distributed application instead of a monolithic application that runs on a particular hardware stack. So a lot of things that you used to assume are no longer valid. And as an application developer, think about these things as well. Breaking down the monolith, right? So one of the reasons we go with microservices and organizational changes. So my previous slides, organizations are now changing, so they're embracing agile approach, and you need to be able to adapt the way you develop software as well to get for that. So it's the other way around. SOA versus microservices. When first thought about microservices, I thought, well, it's just SOA, service-oriented architecture. What's different about it? Change will move from WS spec to sort of REST world, more lightweight communication there. SOA has canonical model. That's contrasted with bounded context in microservices world. That's interesting. Shared database and tight coupling in SOA versus loosely coupled database per service, polyglot persistence. This is a concept that I was struggling with. How do you actually go about implementing polyglot persistence in real world? So this is how I see sort of to fix this image to fix the problem with SOA. You have canonical data model that's shared across all of the services and database is shared as well. So the two resource introduce complexity across the board. Now, when you move into the world of microservices, you tend to break the code down into pieces that fit into small one developer's head. That's the idea. They're individually scalable. You add improve fault isolation. So if one microservice fails, you can recover that the failure is contained. Polyglot architecture, so you actually use multiple programming languages if you want to, and you can, most importantly, integrate with them. Some of the drawbacks, you are now implementing a distributed system. We've got partial failures that are difficult to deal with. Testing is really hard. Operational complexity has just increased. And you now have to deal with CI/CD pipelines, and you need to change your operational organizational structure. So how do you deal with operational complexity? So previously you've had to manage your virtual machines, deploy your code, and take care of the stack. In order to reduce that, I suppose the only way to go about that is actually to use something platform as a service. So Geode platform is one of the examples. So what you do is just give your code to the platform and say, here's my code, platform, go ahead and run it for me over here now. So you're reducing the operational complexity that way. DDT is actually surprisingly an old concept and quite important in event services, event-driven services. How many of you guys are actually familiar with DDT? See most? Yep. Right. So you tend to think about the main model and focus on business context, and you just design a different domain model for microservice with that focus in mind. Check out this book that's been published by Eric. It's been published in 2003, I think. Very famous. That will give you some ideas on how to go about designing your bounded context. So it's just an example of bounded context. Idea is to make sure that you reduce coupling. So your model is contained within a single microservice, and bounded context may not spread, cover multiple microservices. I thought I'd throw this one in as well. REST with crude. It's sort of an anti-pattern. Some developers tend to think about web service or microservices as database service. You've seen this before. We are trying to move away from that. So I think what I'm trying to emphasize here is that bounded context is important. So event sourcing. So it's kind of a foreign concept. Well, I sort of struggle to understand first. You are not storing state as it is now. So in a traditional database, just think relational database, you are storing your the last state, but crude pattern, right? So you're only storing what the current state is of data, right? So you're not storing what the data was yesterday, the day before, historical. The way to go about, so my event sourcing allows you to store sequence of events and be able to, you will be able to reconstruct the state at any given point in time, including the current time as well. So if you guys are familiar with Apache Kafka, you actually go about publish your events to Kafka, and you will be able to query Kafka and get your latest state that way. So you store your events in the event store. So replaying events, so you'll be able to replay events in your state. This is very different to crude. It's event only, right? So this changes your mindset. You never change your data as in crude. you can only go and fix. So let's say if you have an example where there is a defect in the system and you need to go and fix your data. What do? You go in and apply further changes and again to what's already been stored. What happens if you have way too much history and you need to reconstruct state? You can use something like snapshots. So you replay data to a point in time, store it as a snapshot, and then you continue into history. So this is an example of an architecture space that has everything in it, where you can do some of the examples we can do with event sourcing. So on the left-hand side, you would have a microservice presentation layer. So potentially this could be a mobile application with events coming from EUI, and these would be stored or published to microservice as events, and we would have a domain model in that microservice that is now right focused. So the main model here is focused on how you design your storage. So how do you go about designing the main model from writing to the event store. With this particular architecture, you also have the ability to design different views of your data as they get queried. So now we think about analytics. So analytics is another dimension of data-driven application that's sort of overlooked. How do you go about exposing data that you have in an operational system for analytical consumption? This is something that interests me. It is hard. BI is really difficult. It's error-prone, and BI projects fail all the time because of the fact that you have data models, the main models that are being consumed by groups that have no idea how the data was produced in the first place, so they don't really understand the models, and the data that's stored in the first place was optimized for perhaps storage in a relational database, not for analytics. With this architecture, what you can do is solve a massive problem with distributed transactions. So, as we previously mentioned, when you design a microservice, you can't set a microservice. You have to deal with it. You're dealing with a distributed system like that. Previously, when you've gone and designed a distributed transaction in an analytic application, you would just let the run transaction in the database across your multiple tables, multiple models, I suppose, and the database would take care of consistency for you. You can't really do that in a distributed system, so you really need to think differently about how you design your system. So event sourcing just kind of solves that problem for you, because as events come through, originate into your system, into the event store, they can then branch out to relevant consumers as well. So you don't really have to run a two-phase commit on the transaction. What happens is you're eventually consistent on the data. So eventual consistency is really important. And a lot of the systems like Amazon and Facebook will be using this concept. So you persist data, and then you're eventually consistent on the read. And there are different tricks you can do to make sure that that delay is not really visible to the going through the data. So benefits of event sourcing. I've covered some of these. Concurrency issues are solved in some ways. Object relational impedance mismatch problems. So with microservices, ORM is still a problem. when you have a data access layer, is which can be really hard if you have a lot of dependencies on microservices. So that's the idea. Right, drawbacks of event sourcing is it's not a high level, top level architecture, so you need to be careful when you process. One of the initial steps towards one of the cornerstones to event sourcing is a subset. So it's a command query responsibility segregation. Some of these concepts are already sort of covered, but I can outline it for you guys. So you're separating writes and reads. That's the idea. So benefits of CQRS, you can scale query and write separately. So think about that. You can have so like usually, commonly you have a ratio of 1 to 100 in writes and reads in applications. So if you have a single database, you design your optimize the database for writes, but then you need to get the data out. You reduce complexity because now you have more flexibility in the way you design your domain model website. Drawbacks, zero. And that's complexity. So this is the simplest representation of CQRS. You have UI and commands, so the job some sort of computation beginning. So what happens is that as an event come in, you would store it in the database, and immediately after that you publish it to a queue, and that queue is then eventually consistent to a particular cache that then becomes a query later for you, right? So you would, on the left you would write to it, on the right you query. And that's pretty much it, very simple. So this is where you're moving from, so this is your microservice, you've got your own model and database, you move into this time world, where on the left you've got the command query, and on the right you've got query. So you may have multiple query services, so you can imagine this could be your application on the right, or that could be analytical service as well. The query model can be very different. You could have denormalized and normalized type models as well, and you can scale these differently as well. So I just wanted to briefly talk about GemFire. So GemFire is a product that we have a pivotal that kind of lends itself nicely to CQRS. Just happened to be so. GemFire is a distributed memory database with strong data consistency. So it's linearly scalable and it was designed for low latency transactional applications and high concurrency needs. You can think about applications that you can have multiple, couple of million users using this database. So it's a memory, in-memory object store. So implementation of CQRS and GemFire days, you would actually go and create multiple partition regions. So we've got three GemFire service here, writing events to GemFire. And what happens is you can define two partition regions. So think partitions as a table. Right? So each one of these tables will have different model, data model, and you can scale them differently in GemFire. Right? So you would write to the top partition regions. So they're partitioned by so these are GemFire. Think of GemFire that has no shared nothing architecture. So you're sort of like sharding. Right? So portion of data can data is partitioned across different ones, and that's how you achieve that linear scalability. So you'd write to the right And what GemFire allows you to do is implement continuous queries. Right? So the problem with CQRS is that the synchronization between the write and query view. That synchronization is kind of a problem. How do you explain your patch? It's a hard data science problem. But that's solved nicely in GemFire because you have continuous queries which are event-based, and you could essentially implement your query view, which is always in sync. As the data comes in, you can then go and publish it. So how do you go about implementing this in Spring? This is one of the examples that, if you guys are interested, check it out. There is a GitHub project that's implementing one of Geode guys. It's all in Spring stack, so uses Netflix OSS, Spring Cloud, and so just I think the focus here is microservice and including microservice. So everything else is Netflix and some of the other products that we have. So in this context, we have Spring Cloud config, which is a distributed way of configuring your microservices. In the Spring Cloud Netflix stack, we have Eurocurrent service discovery, Zool gateway as a service gateway, and Ribbon as a load balancer. So an example here is Spring Cloud Stream. This is the publisher. So we've got input channel adapter, like the code example, that's publishing events to the consumer. So this is your typical event-driven world that's implemented in Spring Boot Stream. So Spring Boot Stream is a framework that's built on Spring integration. So it uses the same integration patterns, and Kafka can be the middle way here, or as a previous example, check out Project Reactor. The next focus is going to be on RS Java, so that sort of lends itself nicely with the continuation. Event stream, event sourcing is a really nice topic to think about in the context of data-driven services, data-driven microservices. But this is just one of the areas that's been touched by Reactor. So Reactor is quite a really exciting area, such as UI as well. So we're sort of getting into a different paradigms of different applications where they're all event-based. Go to spring.io, start spring.io, you'll be able to generate a lot of, get started with some of the projects quite quickly. And I think that's it. So do you guys have any questions? So this is sort of, just to give you an idea, this was a bit of research that I've done recently, so I'm not a Java developer, I'm not a Spring developer, big data guy, but I just found it fascinating because it crosses over to analytics and data. And I think there's sort of a trend that's worth sharing.
Yeah, are there particular applications that you'd recommend event sourcing over using a traditional database and vice versa?
What type of applications?
Yeah.
Yeah, so distributed apps. So think about your large-scale applications that they do need that kind of flexibility on the read and write. I think when I think about these sort of solutions, I think about data-driven services or data services. So we have data science, so we need to stream data from the sources to straight to the consumer, right? So that could be a mobile app. Analytics as well. You need to run your real-time analytics. And also, some of the use cases I'll be looking at is being able to use the same pipeline for batch and real-time streaming. This allows you to do that. And it's really exciting because previously we've been forced into things like really awkward architectures that allow you have to manage batch and stream separately. And unifying that it reduces a lot of operational complexity.
You said event sourcing is not a top-level application.
No.
I know what you mean by top-level application.
Well, that was a quote from Great GemFire, so I'm just messaging it. But the thing is, from other people's experience, it looks like if you implement this across the board without religiously, I think you actually introduce a lot of complexity in microservices. You're baking in events, a lot of implied logic everywhere through these events, and it's really difficult to then make sense of what's going on in your service and your services. So you need to go and debug everything and trace code in order to actually find out what's going on. So you've got to be careful. But these sort of frameworks make it easier for you because I'm thinking about it as a pipeline, and basically you're a stream of events and you can channel your data straight to your apps or to your database. It's a nice architecture.
You mentioned GemFire. Is that something you've worked with much?
Yeah, I work with GemFire.
Okay, so I guess the question I had is related to that. A lot of these big data distributed things are quite easy for developers to run up locally, in instance, and it's working nicely. And then you go to deploy it, run it in prod, and it introduces some additional operational complexity compared with the centralized database. Just wondering how you found GemFire.
GemFire is so GemFire is actually an open source. Apache Geode is the open source version. So Kravtsov open source it quite recently. It's traditionally been in financial institutions. Yeah, I mean, obviously you will have additional operational complexity, but it really depends how you use it, whether you use it correctly or not. And that is important because we have some clients that sort of abuse it a little bit and then get complaints. But GemFire is surprisingly quite lightweight. So it's quite easy to use if you understand how it works. And it's sort of the case with a lot of NoSQL databases these days. You look at the standards, it makes things easy in some ways, but operationally it's actually quite hard to work with in real world. I mean, you really need, like, if you're going to deploy at scale, you need 1 or 2 resources, full-time and dedicated.
A comment on not using event sourcing as a non-high-level architecture was event source. It should be transparent to the users of the service that use event source. It's just a tool to manage a certain type of operational complexity within a service. So it's a service architecture, whereas something like domain-driven design as an architectural principle would sit above that. And as someone using an event source service, you should just have a funny asymmetric API instead of a traditional symmetric API. An interpretation of that.
Any other questions?